Computers can store information in three basic locations, either in RAM, persistent storage, something like a hard drive, or via a cloud-based storage solution. Storing information in RAM is achieved when we use variables. When the app is killed, we lose the information in those variables. To ensure that information is preserved between app launches, we need to store the data in persistent storage or in the cloud. We won't be covering cloud storage in this particular course. Ionic runs in a browser on the phone, therefore any HTML5 based web storage options are also available. The following are common web storage options. So we've got local storage, indexed DB, or WebSQL. We will briefly cover how each of these work and then look at Ionic's storage module that provides a unified interface for different types of storage. When running in a native app context, that is when we're on an actual mobile phone, then another option is available, which is SQLite. This has benefits over the other web storage options because of its ability to use relational database techniques. Local storage is a HTML5 based option that allows us to store name-value pair-based data locally within the browser. Local storage is a replacement for cookies and is more secure and able to store larger amounts of data, at least 5 megabytes of data. Amounts over this 5 megabyte size limit then is dependent on the browser and its need for resources. Web storage is per origin. All pages from one origin or domain can access the same data. Using local storage in JavaScript is very simple. These are the basic commands. We have our local storage.setItem where we have a key and our value, or our name and value. We have our local storage.getItem where we just have to reference the name and it will return the value. Or we have our local storage.removeItem where we reference the name and then it will delete that value. There are some limitations with local storage. So local storage may be limited to 5 megabytes per website. The browser may remove storage without notifying the page. There's only one global namespace, and there is no support for advanced queries, tables, or SQL. And on the security side, data is accessible from any web page served from the same domain. IndexedDB is a low-level API for client-side storage of significant amounts of structured data. IndexedDB is designed to replace both local storage and WebSQL. WebSQL was an API supported by Chrome and Safari to provide an asynchronous transactional interface to SQLite. Operations performed using IndexedDB are done asynchronously so as not to block applications. IndexedDB is a transactional database and does not use columns and rows as other relational databases do to store information. IndexedDB databases store key value pairs where the value can be a complex structured object. All operations on an IndexedDB database are built on transactions. These transactions allow for data to be locked while a transaction is occurring to prevent any modifications being interfered with and potentially allows for rollbacks if an error occurs. IndexedDB has a few advantages. It is more reliable than local storage. It allows for different collections to be created, similar to tables, and to create namespaces. It allows for more advanced queries, and it supports transactions. Now that we've looked at a few different storage options that are available to most web-based applications, let's have a look at what the Ionic framework has provided for us to simplify this process. Ionic provides a storage module that provides an interface to multiple storage options. In mobile, Ionic will use the following storage options in order of availability. It'll use SQLite if we're actually on a native mobile device first, followed by IndexedDB, WebSQL, and finally local storage. However, you can also configure the storage module to use a specific preferred type of storage. Just note there that SQLite is not available to web pages, but it is available on mobile devices if the Cordova SQLite plugin is installed. The Cordova SQLite plugin can't be used when testing in the browser. It's only available when testing on either a device emulator or an actual device. Using Ionic storage is very simple and similar to local storage, even if you're using more advanced underlying storage options like SQLite or IndexedDB. You will need to install the Ionic storage module via npm. So remembering npm, the node package manager, using the install option, the --save adds this module as a dependency for your app in your package.json file, and we're going to be calling the Ionic storage module. Once you have used npm to install the module, you will need to import the Ionic storage module and include it in the apps module. Next, add it to the ng module decorator imports array. The for-root method defines this as a singleton and makes it available across the entire application. This is important for lazily loaded pages. In the following example, we're going to build on our previous exercise of a login screen so that we can remember if the user has logged in. There are a number of states we need to consider. Whether the login tab is shown, we need to retrieve the logged in username if there is one. When the user logs in, we need to store the username. Ionic storage uses key value pairs and JSON, which is JavaScript object notation, objects. In this example, we will have the one key called username. We are going to need to access Ionic storage from the tabs to page. To add that, we need to inject the storage module like we do with the router. First, we need to import the storage module into the tab to page. Then we need to include an instance of Ionic storage as a parameter in the constructor. The first thing we're going to do is to retrieve the existing value of the username property from Ionic storage and set the username property to that value. This is an asynchronous process, and you can see the promise then syntax being used. The value that is passed back via the promise is assigned to the local instance of username. If we run the code from the previous slide, the first name field appears empty because we are not storing anything yet. In the login function event handler, we will store the contents of the username property into the username key of the storage object before navigating to the account page. Here we are associating the key value pair with username being the key, and this.username is the value. When we log in, the username is stored. If we reload the app in the browser, the username is loaded from storage and appears in the input field automatically. You may have a scenario where you need to retrieve multiple values before performing an action. For example, you may need to retrieve both the username and password before checking if they are correct. Because the retrieval occurs asynchronously, performing the login check after reading the username or password doesn't guarantee that the other property has been read. In this example, it is possible that the username hasn't been read yet because it is being read asynchronously. We can use promise chaining to ensure a previous value has been read before reading the next value. When the first promise is resolved, it assigns the returned value and is assigned to this.username. Only then does the second promise begin, which when resolved, saves the returned value to this.password. Finally, the username and password are compared for authentication. This is a perfect example where the async await syntactical sugar will make it more readable. However, we can't use async on constructors. Instead, we can place our storage reading code in the ng-on-init and make it an async function. We would then have the values for username and password to do any authentication that is required.